Hey, good morning. So I normally wouldn't want to do this on a Wednesday, make a video like this, but I'm going to be out on Friday, so I feel like to prevent us getting too far behind, I'm going to go ahead and make a video here to kind of introduce maybe the next thing, the next technique of integration, and at least get us sort of started on it, and then we'll do some more stuff hopefully tomorrow. So if you see on the board here, I've got an algebra problem here. X over x plus 2 plus 2x over x minus 4. This isn't really a calculus problem right now. Like I said, this is an algebra problem. So we're going to go ahead and solve it, or do this arithmetic like it says. We're going to add these two fractions. You'll see why. Sorry, I had to go and get a marker. So if you remember adding fractions, they need a common denominator, right? So this guy right here, he needs an x minus 4. So I'm going to multiply him by x minus 4 over x minus 4. This guy right here needs an x plus 2 to get a common denominator. So we'll multiply by x plus 2 over x plus 2. And then I'm going to have x squared minus 4x in the numerator there. And the denominator is going to be x minus 4, x plus 2. And then over here, I'm going to have 2x squared plus 4x over x minus 4, x plus 2. And then I can write that as one big fat fraction. So I can combine the numerators and say this is equal to what? 3x squared minus 4x plus 4x, I guess plus 0. So go ahead and write it. Over x minus 4 times x plus 2. Okay? So we're just reviewing adding fractions with a common denominator. Now you might say, why are we doing this? Okay? Well, in calculus, in this course, what we're going to be doing is we're going to be starting with something like this. Maybe I'm going to give you this problem. And I'm going to say, find the antiderivative of that. Okay? And when we find the antiderivative of that, the technique that we're going to use is we're going to break this up into those original two fractions. Okay? So that's sort of what the goal is. This is called partial fraction decomposition. Okay? So what we're going to do before we do the integrating, I've got to teach you how to do the algebra of decomposing a fraction or a set of one fraction into two or multiple fractions into an addition problem. Okay? So that's what we're going to do. But again, I had to review that adding fractions because apparently we forget how to do that. So let's start off with an example here. Here we go. So again, this is not calculus so far. This is just going to be a little bit of algebra. So 2x plus 2 over x squared minus 2x minus 15. Okay? So there's an expression. What we're going to do is we're going to break that into an addition problem of two fractions with a non-common denominator. Okay, so the first step that we're going to do here is we're going to factor that denominator. Because if you notice, when we added those two fractions together before, it was the resulting answer that we got when we added them, we had a denominator that was factored. So if I factor this denominator, I'm going to get x minus 5, x plus 3. Okay, you can check me on that. All right. So now, here's where the decomposition comes into play. Again, we're not doing any calculus here. We're just doing some algebra. All right, so I'm going to take this fraction right here, and I'm going to say, hey, this looks like someone just added two fractions together and got a common denominator. And I'm going to say the two fractions were something, I don't know what, over x minus 5, plus something else, I don't know what, over x plus 3. Okay? So now what I'm going to do is I'm going to figure out what these two somethings had to be so that the result was 2x plus 2 when I added the fractions together. Okay, so just like before, I'm adding fractions together. I need a common denominator. So this guy here, I'm sorry, this guy here needs x minus 5. Oopsies. And this guy here needs x plus 3. Okay. And so now I've got a times x plus 3a over x minus 5 times x plus 3. And then I've got b times x minus 5b over x minus 5 times x plus 3. Okay? So now I'm going to add these two things together. So I'm going to say this is equal to ax plus bx plus 3a minus 5b over x minus 5 x plus 3. Okay? And now you might think, well, what do I do here? This is stupid. What are we doing? Okay, so let's recap. What is it that we're doing? Well, we're trying to figure out what a and b are so that when I add these two fractions together, I get this original starting fraction. Okay? So you can see this original starting fraction has a coefficient on x. It's 2. And then it has a constant, which is also 2. So what I'm going to do is I'm going to organize this numerator right here. And I'm going to say this is the same thing as a plus b times x. I'm going to factor out the x there. And then plus 3a minus 5b over x minus 5 x plus 3. Okay? Now, a and b are constants. A and b are going to be just constants like 2, 7, -7, -8, and whatever, 1/3, whatever. They're constants, all right? But if you look carefully at the structure here, we've got something, a plus b is going to be something times x, and then I've got 3a minus 5b hanging out over here. Well, if this has to equal the original, which was 2x plus 2 over x minus 5 x plus 3, if that has to be true, then what's a plus b have to equal? Well, a plus b is the coefficient on x. What's the coefficient on x? 2. And what does 3a minus 5b have to equal? Well, this is the constant part, right? What's the constant part over here? 2. So now, friends, you have a system of two equations and two unknowns. Wow, this is a lot of algebra. Yes. You have a system of two equations and two unknowns that you've got to solve for a and b. Okay? So the quick way to solve this might be to multiply this guy by 5. So we have 5a plus 5b equals 10. And then add those two together. So that's 8a equals 12. A equals 12 over 8, I think. Does that sound right? Now you can reduce that if you want, or simplify that if you want. Simplify it to what? 4 goes in 3 halves, okay? And then b, you take this, plug it back into one of the equations and solve for b. Just to save time, I'm going to do that for you. You get 1/2, 4/8. Okay? So a is 3 halves, b is 1/2. So now, if I go back to the original problem, we have decomposed, we have deconstructed this fraction into a, 3 halves, over x minus 5, plus b, which is 1/2, over x plus 3. Okay? So this fraction equals these two fractions added together. Okay. So if I were to, start off at the, if I were to start off the video with adding these two fractions together using a common denominator, I would get that. Now you might say to yourself, well, who cares? Why do I want to do that? Well, the reason why we want to do it is because if I gave you this problem right here as an antiderivative, that would not be very much fun. But this problem, if I anti-differentiate each one of these individually, it's actually really, really easy. Think about what the answer would be if I just gave you this problem and said, hey, find that antiderivative of these two terms individually. What would it be? It'd be 3/2 natural log of x minus 5 plus 1/2 natural log of x plus 3. Okay, I did the u substitution in my head. But yeah, it would be that easy. So that's where we're headed. Okay, but we've got to figure out how to get there first. I mean, we got to do some practice on this deconstruction thing, this decomposition. All right, so let's look at another example. I guess I have to erase the board. Since I'm not using Screencast-O-Matic, I can't pause. I'm just recording this through YouTube Live, and then I'm going to send you the link to the video. So you have to watch me erase the board. All right, so I'm going to change colors because I feel like this marker's dying out on me. All right, so here we go. Here's another example for us. How about 1 over x squared minus 4? Okay, so we're going to decompose that into partial fractions. So our first step is going to be factor the denominator. So that's 1 over x plus 2, x minus 2. Okay, and then I'm going to say, well, that's going to equal something over x plus 2 plus something else over x minus 2. Okay, and then when I add these fractions together, this guy needs x plus 2. This guy needs x minus 2. So I have a times x minus 2a over x plus 2, x minus 2. And then I've got b times x plus 2b over x plus 2, x minus 2. Write those as one big fat fraction. ax plus bx minus 2a plus 2b over x plus 2, x minus 2. And now group this stuff together, okay? So I've got a plus b. This is what you're always going to end up doing. Factor out that x minus 2a plus 2b all over x plus 2, x minus 2. And here we are. Okay, so let's set up our system of two equations and two unknowns. Are you ready? Well, a plus b has to equal what? Well, if I go back here, what's the coefficient on x? It's 0. So a plus b has to equal 0. And then negative 2a plus 2b has to equal that constant, 1. So here's our system of two equations and two unknowns. Solve that. This one, I think it's easier if I say a equals negative b. So negative 2a plus 2 times negative a equals 1. So that's negative 4a equals 1. A equals negative 1/4. B equals positive 1/4. Okay? So now our fraction, our original fraction, can be deconstructed into negative 1/4 over, which was a was over x plus 2. It's very important that you be consistent with how you set this up. Whatever you got for a over here, that's what's got to go right here above x plus 2. And then b, it was positive 1/4. In fact, when I worked this out ahead of time, so I could get the numbers, I switched these around. I put a over x minus 2 and b over x plus 2. So I reversed that. So my a over here, when I did it, my a ended up being positive 1/4, and my b ended up being negative 1/4. That's what will happen. You'll get the same end result right here, but the values of a and b might be different if you switch that order around. Okay? So this fraction right here deconstructs into the sum of those two fractions. All right? So that's another example for us. Now I'm going to give you I'm going to tell you a shortcut tomorrow, I think. I think the shortcut might be easier to explain in person. I don't know. We'll see. Let's do another example. Maybe I'll teach you the shortcut midstream. So let's erase this. This marker is kind of dying too, so I want something that's pretty bold on the board for you. Here's another one. I'll just leave that up there. 2x plus 1. Oh, yeah, that's good. 2x plus 1. And I'm going to go ahead and factor this. Uh-oh. What are you thinking? I know what you're thinking. You're thinking, oh, there's 3 factors there. How do I do this? Okay. You do it the exact same. Ready? You're going to say this is equal to something over x plus something over x minus 3 plus something else over x plus 2. Okay? Now, I do want to point out that all the examples so far that we've seen, the denominator factored into non-repeating linear factors. What do I mean by that? Well, all of these are of degree 1, and they don't repeat. So meaning that we didn't have any that looked like this, where the denominator was like x minus 2, x minus 2. Okay? When that happens, we're going to set this up a different way, and that'll be tomorrow. Okay? So these are all non-repeating linear factors. Degree 1, and they don't repeat. All right, so let's go ahead and set this up to add. All right, so now we've got 3 fractions to add together, all with a different denominator. So we've got to find a common denominator. The denominator is going to be the product of all 3. This problem right here is an Algebra 2 teacher's dream. It's just like so much Algebra 2 here, okay? So this guy right here, what does he need? Well, he needs the other 2. So he needs x minus 3, x plus 2, x minus 3, x plus 2. What's this guy right here need? Well, he needs an x and an x plus 2. And what's this guy right here need? Well, he needs an x and an x minus 3. So now I'm going to add those fractions together. Well, first I'm going to do the distributing property here. So I'm going to say that's a times x minus 3, x plus 2 over x times x minus 3, x plus 2. Don't cancel this out, by the way. That would undo what you just did. B times x plus 2 over x times x minus 3, x plus 2. And then C times x minus 3 over x times x minus 3, x plus 2. Okay, woo, baby. So now I'm guessing that you're seeing that we're going to end up with 3 equations and 3 unknowns, okay? If you don't see that, you will here in about 2 seconds. But let's go ahead and finish this out. So if I FOIL this, if I want to use that as a verb, that's going to be x squared plus 2x minus x minus 6. And then this is going to be b times x squared plus 2x And then this is going to be c times x squared minus 3x all over x times x minus 3 times x plus 2. So now I've got ax squared minus ax minus 6a plus bx squared plus 2bx plus cx squared minus 3cx. And I sometimes do this because I get lazy and I don't want to write that denominator over and over again. I just put d for denominator there because really the numerator is all we care about right now. So now I'm going to group all this stuff together and I'm going to get ax squared plus bx squared plus cx squared minus ax plus 2bx. Let's check these off here, just make sure I get them all. Minus ax, 2bx, minus 3cx, and then minus 6a. Looks like I got everybody all over the denominator. And I'm running out of room here, but I'm going to factor out x squared here. So that's a plus b plus c x squared plus, I'm going to factor out an x out of this. So that's going to be negative a plus 2b minus 3c times x, and then minus 6a. Okay. Ugh. So now we can do this thing with equating the coefficients. We're going to go back up here and we're going to look at this. Okay? We're going to look at that. And we're going to say, all right, what's the coefficient on x squared up here? Oh, there isn't one. So it's 0. So a plus b plus c has to equal 0. Okay? Down here, this is determining the coefficient on x. What's the coefficient on x up here? It's 2. So negative a plus 2b plus, minus 3c equals 2. And then the constant hanging out on here. We only have this guy right here. It's dictating the constant. So that's negative 6a equals 1. Okay? So there's 3 equations, 3 unknowns. Figure out what a, b, and c are. Okay? This might be a good time to show you the shortcut. How's that sound? Okay? So if I go through and solve this system of equations in 3 unknowns for a, b, and c, okay, I mean, I think it's pretty clear a is negative 1, 6. We can already kind of conclude that just based off of what's written there. Okay? But here's the shortcut. Okay? Here's the shortcut. You don't have to do any of this work right here at all to do this shortcut. Okay? You don't have to do any of this work at all to do the shortcut. All you have to do is this first step right here. Okay? Set up the decomposition. And this is called the heavy side cover-up method. You set up the decomposition. Okay? Set this piece up, these 2 things up right here. Okay? And now we're going to go and figure out what a is. Okay, ready? Here we go. So a is over x, all right? So then what you do is you go back to the original problem, this original structure here, and you say, okay, I'm going to look at this factor x because that's what a was over. And I'm going to say to myself, what makes that factor 0? And the answer is 0, all right? So then what I'm going to do is I'm going to cover this up imaginarily, cover that up, and then I'm going to plug in 0 for x everywhere else. So if I plug in 0 for x everywhere else, I get 2 times 0 is 0, plus 1. So 0 plus 1 is 1. I'm going to jot that down. 0 minus 3 is negative 3. 0 plus 2 is 2. Negative 3 times 2 is negative 6. So that's 1 over negative 6. That's a. Okay? That's simple. Let's do B. Okay? So ready? Now B is over x minus 3. So I'm going to go over here to the original problem when it's in factored form. And I'm going to say, okay, whoop, I'm going to cover that up. What makes it, before I cover it up, I have to decide what makes it 0. What makes x minus 3 0? 3. So I'm going to cover that up. 2 times 3, 6, plus 1, 7. Okay, now I'm going to plug 3 in for x here. 3 times 3 plus 2. 3 plus 2 is 5. 3 times 5 is 15. So 7 over 15, that's B. And lastly, okay, why don't you pause the video, try to see if you can figure out what C is, and then you'll see me do it. Ready? Here we go. Negative 2 makes that 0. So I'm going to plug in negative 2. So 2 times negative 2 is negative 4, plus 1 is negative 3. And then negative 2 times negative 5 is 10. So C is negative 3/10. Okay. So there's A, there's B, there's C. So I could write this as negative 1/6 over x plus 7/15 over x minus 3 plus negative 3/10 over x plus 2. Okay? That's using the Heaviside shortcut cover-up method, whatever you want to call it. I'll do another example of that for you here after I erase the board. We'll do one more where we use the shortcut. And then I'm going to give you some problems just to try to do this decomposition. Again, we're not doing any calculus right now. Surprise. It's all algebra. But we'll do one more example with the shortcut, and then I'll turn you loose to try some problems on your own before we actually start integrating. All right, let me erase this. So your first question is probably, can I use that shortcut? And the answer is yes, you can use the shortcut, but the shortcut only works when you have non-repeated linear factors. Okay? It only works when you have non-repeated linear factors. So I'm going to have you do a couple where you don't use the shortcut, and then you can do a few more where you do use the shortcut. You still got to be able to solve a system of equations, because the ones that don't, like I said, this only works on non-repeating linear factors. The ones that have something other than that, you have to set up the system of equations. Okay, here we go. Let's just make something up here. How about 3x plus 2 over x squared minus 9? Okay, so we're going to break that up. First, we're going to factor the denominator, and then we're going to say, okay, that's equal to a something over x plus 3, and then something else over x minus 3. All right, here we go. So let's figure out what a is. So a is over x plus 3, so negative 3 makes that 0. I'm going to cover that up and plug in negative 3 for x. So that's negative 3 times 3 is negative 9, plus 2 is negative 7. And the denominator is negative 3 minus 3 is negative 6. So negative 7/6 is A. Or 7 over negative 6, whatever. Okay, B. 3 makes that 0. So plug in 3 for x. 3 times 3 is 9, plus 2 is 11. Over 3 plus 3 is 6. That's B. So there's our partial fraction decomposition for that. Didn't have to set up the equation. Okay? If I were to set up the equation, I would have gotten a times x minus 3 over x plus 3, x minus 3, plus b times x plus 3 over x plus 3, x minus 3, And then I would have had ax plus bx minus 3a plus 3b over x plus 3, x minus 3. And then I would have said, okay, a plus b times x minus 3a plus 3b over x plus 3, x minus 3. And then I would have equated the coefficients. So what's the coefficient on x in the original? 3. So a plus b has to equal 3. And then negative 3a plus 3b has to equal 2. If I solve this system of equations in two unknowns, if I was solving for a and b, I'm going to get negative 7/6 and 11/6. Okay? So that's an introduction on how you decompose a fraction into separate partial fractions. Again, this only works when you have non-repeating linear factors. Okay? What do I mean by non-repeating linear factors? The degree is 1, and they don't repeat. Like it's not x plus 3, x plus 3. Okay? If that happens, then we've got to do something else, which I'm going to show you tomorrow in class, hopefully. So yeah, that's all. I'll have some problems for you to try in Google Classroom, and it's just going to be doing this decomposition. It's not going to be doing any calculus, but you got to get practicing on the decomposition. So that's all. I got to walk over here, hit stop. Have a great Wednesday.